Hi, Chelsea. How are you doing?
Hi, sir. I'm good. How are you?
Very good. Very good. So tell me, in maths, what are you doing now?
So in a few days, I have a test or quiz coming up on chapter 6.4, 6.6, and 7 in the Nelson textbook. So transformations and modeling trigonomic functions.
Okay. So can you just share with me what are the topics, and then I'll teach you those topics and answer your doubts.
Okay, thank you, sir.
Let me share. Okay, you can now share. I'll know exactly what you need to do or need to understand. We'll get into that. So you're given
Okay.
some trigonometric functions. We need to figure out after transformation, how do you sketch the graph? Perfect.
Yeah.
Okay.
Um,
Hmm. Move forward. So some application questions. Then you are finding the equation from the graph, right? Can you please read the key summary here? Can you please read the summary?
yes. Key ideas. The graphs of functions of the form f of x equals a sine k x minus d plus c and f of x equals a cos k x minus d plus c are transformations of the parent functions y equals sine x and y equals cos x respectively.
Correct. Hmm.
Absolute value of a gives the vertical stretch and compression factor. So
Correct.
if a is less than 0, there's also a reflection in the x-axis. 1 over k gives a horizontal stretch or compression factor. If k is less than 0, there is also a reflection in the y-axis. D gives a horizontal translation, and C gives a vertical translation.
Perfect. So let us try to understand all this, correct? So just I'll open a white board for you, and then from there I'll share the screen, whiteboard for you. Now here we will do what we have learned in this particular chapter, what you need to learn in this particular chapter, right? So first thing, when we talk about the functions, we know the standard function is y equals to sine x, right? So we call this as sinusoidal functions, right? This is called the parent function.
Mhm.
Also, we had been looking into y into cos x. However, when we say sinusoidal function, we mean sine x. Do you understand? Mainly because sine and cosine are actually the same waves, right? So if I have to draw a sine function, it will be like this. You see that? So that is sine function which starts with 0 at the origin, and it will go to a maximum at, let's say, pi by 2, comes to 0 at pi, 3 pi by 2, it will be minus 1, and at 2 pi, it is going to be 0 once again, right? So here we have y-axis, y equals to sine x, and here we have x-axis. Now this particular unit, which I have shown you, is called one cycle. The function is periodic. So that means the cycle repeats. This is the second cycle. Is that correct? So the cycle repeats. Because it is periodic. So one cycle time period t is 2 pi. We see that the maximum is basically at pi by 2 and its value is 1, correct?
Yes.
And as far as the minimum is concerned, that minimum is at 3 pi by 2 and it is minus 1, correct? So that is your sine wave. Now the question is, why do we consider only sine as their parent function? I know in the book they have written both sine and cosine. However, if you see what cosine is this way, correct? So what has happened, if you look into the transformations, what you notice is that every point has moved back. I mean, I should say this, right? By how much? Pi by 2. Do you see that?
Yeah.
So that means we say cosine leads by pi by 2, which is basically quarter of a cycle. Do you notice that? Leads
Mhm.
means that maximum value for cosine came first, correct? So it is kind of translation of sine to cosine, where horizontally it has shifted pi by 2 units left. Is that clear to you?
Yeah.
Pi by 2 units left. So that is what it is. If you see from cosine angle, in that case, the sine wave is basically, if you look at this particular point, the sine wave corresponding point is pi by 2 later, correct? So you could write this as cos x is equal to sine of x minus pi by 2. Is that clear to you?
Okay. Yeah.
So that is very important relation. That means that horizontally, the cos wave has moved pi by 2 units to the right. One cycle is 2 pi, one cycle is of 2 pi, and pi by 2 is 1/4 of that cycle, correct? So one cycle t is equals to 2 pi, and what is t by 4? It is pi by 2. Is that clear? 2 pi divided by 4 will give you pi by 2. Is it okay?
Mhm.
So quarter of a cycle is what the phase shift. We also call this as phase shift. So I have added few more terms in what you have learned in the chapter itself, correct? So what did you learn? Can you summarize?
So we learned that sine x is a parent function.
Yes.
So it's basically the same thing as cos x. The only difference is that cos x starts at the maximum point,
Yes.
where sine x starts on 0.
Yes.
And then we learned what a cycle is, which is a full period of one wave on the graph. And then also that one cycle can be divided into 4 segments, which is pi over 2.
Correct. Correct. Now the concept is, let me clear the screen and get to the basic concept. Why did I divide a cycle into 4? Can you tell me that?
Because maybe easier to translate.
Okay,
Or
because there are 4 quadrants. See, now let's relate to our learning, right? We know the cast rule, correct?
Mhm.
We know this quadrants are 4 in number: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So when you are talking about a sine wave, we are trying to move a point which is, let us say, on a unit circle, correct?
Mhm.
And if I have a point on a unit circle, let's say this is my point on a unit circle, xy. And this r is equal to 1 because I'm talking about a unit circle, correct? In that case, if this is the angle, which I'm saying theta now, so what is sine theta equals to? Sine theta is opposite side, which is y, over r, correct? Since r is 1, sine theta is y. Now, if you start with a point which is right here on the x-axis, then what is the y value? 0, right? So if theta is equal to 0, then the y value or sine theta, which is equal to y, is also 0, right? This coordinate point is 0, 1. Is that clear to you?
Yeah.
As I move this point here, at this particular point, theta becomes pi by 2, correct?
Mhm.
And the y value is 1. As it comes here, the theta becomes pi, correct? And the y value becomes 0 once again, correct? When you move further, it is 3 pi by 2. And the y value is minus 1. And then when you come back to this point, that means when you make your full circle of 2 pi, it comes back to 0. You see that?
Yeah.
So as you move counterclockwise is positive rotation, correct? Sine theta is positive in quadrant 1 and 2, as you can see, correct? And
Yeah.
then it becomes negative in quadrant 3 and 4,
Mhm.
right? So when we talk about sine theta, we talk about the key points, and there are 5 key points. Is that okay? 5 key points, as just I have shown you, are 0, 0, pi by 2, 1, correct? Pi 0, 3 pi by 2 minus 1, and 2 pi 0. So these are your 5 critical points to always consider when you are sketching a sine wave. And the idea is a point moving along a unit circle, the y value gives you the sine. Is that okay?
Yeah.
You will soon understand that the x value gives you cosine. It is 1 now, right? So the
Yeah.
x value gives you cosine, y gives you sine. And therefore, I could also write this particular point as, let me write this as cos theta sine theta. Do you see that? Because the y value is sine theta, the x value is cos theta when we are talking about a unit circle. Is that clear to you?
Yes.
And you see your 5 critical points, and you see why it is so. And why should I divide into 5 quadrants? Do you see? So one full cycle means 2 pi. Each quarter, do you see that 2 pi by 4? Do you see that pi by 2? Correct?
Mhm.
Second quarter, third quarter, fourth quarter. That is how it is really defined. So now you understand how do we get a sine wave? It is actually a movement along a unit circle, the y coordinate, the height or the distance from the x-axis, which is giving you the sine value. And that is where we come to all the application portion. You see that?
Yeah.
So if I have a wheel which is kind of rotating, and let's say this is river water, correct? Then we can say that the height above is positive and height under the water is negative. In that case, the sine value gives you the height as the wheel rotates. And that is where we'll look into the other chapters related to this particular unit, where the applications will come. Is this concept clear to you?
Yes.
Very good. So we'll clear the screen. And now we have understood one thing, that for sine theta, the key values are, can you tell me?
0, 0,
Yeah.
pi over 2, 1, pi 0, 3
Yeah.
pi over 2, and -1, and then 2 pi and 0.
Perfect. So how do we sketch a sine graph? Let me show you the easiest way to sketch the sine graph. We're trying to sketch the sine graph. One cycle, just one cycle. That means I'm saying, well, my one cycle means 2 pi. Is that okay?
Mhm.
One cycle is 2 pi. To sketch this graph, I'm going to divide this into 4 equal. I mean, they are not equal. Let me just do slightly a better job than this. 4 equal parts. So this one cycle means a time period of 2 pi, correct? So this is the time period, which is 2 pi, correct? So as soon as I divide, I get half of it as pi, right? This half of that is pi by 2. And then 1 pi by 2, 2 pi by 2, 3 pi by 2. Do you see that? 4 pi by 2 is 2 pi. As far as the sine is concerned, the maximum value is 1. The minimum value is -1. You know that, correct?
Yeah.
Because it is a ratio of opposite side to hypotenuse, and the hypotenuse is the longest side. When it is 0 or pi, in that case, the longest side hypotenuse coincides with the opposite side, right? I mean, adjacent side. So the height becomes 0. Now, the critical points for us will be sine starts with 0. So we go from 0 to the maximum, come back to 0, go to minimum, go back. Do you see how easy it becomes?
Yeah.
All the graphs we are going to sketch like this. That is to say that this is a sine theta, right? Where sine theta means we have a time period of 2 pi. So we actually made a scale and we say, well, this is my angle theta and this is the y value. Y value is between -1 and 1. That is the range for the sine function. And the domain for one cycle is from 0 to 2 pi, right? So we are sketching for theta, which is from 0 to 2 pi. And we're talking about radians. When we do not write any units, default unit is radians. Clear?
Yeah.
Perfect. As soon as I change the function, now let me sketch the second function. We're talking about transformation. We'll get there soon. So if I have, instead of sine theta, sine 2 theta, it means what? Sine 2 theta means within this time frame of 2 pi, that means one full circle, it goes twice. 2 theta, double fast. It is moving faster. Like you, when you cycle and you're going faster and faster, it could be 3 pi, 4 pi, 5 pi, number of cycles which we are doing. So if I do sine 2 theta, in that case, we have two waves here. So in that case, what will happen is that we'll have these points kind of like this. Do you see that? So we are going to split this particular curve. We'll go from here to here, correct? And then to the minimum, and then to, I should go, wait. So what I'm here doing it, I'm just dividing it into more waves, right? So one cycle will finish here now instead of 2 pi. So my points of interest will now be these. So I'll go to the maximum and then to 0 and then to minimum and then to this point. So I have a wave which is kind of like, do you see this wave?
Yeah.
Half. Do you see that half? Correct?
Mm-hmm.
And then again, the next half. You see that? Two waves. Sine 2 theta means now two waves within that interval of 2 pi. So what is now one cycle for you? So we know one cycle time period for this is half of 2 pi, right? So
Yeah.
2 pi divided by 2, which is pi. Is that okay?
Yeah.
If I have an equation which is sine k theta, in that case, what is the time period? 2 pi by k. You understand now?
Yes.
So the
Yeah.
time period becomes 2 pi by k, and all of the things we have just kept same in this particular position. But you see how we have made the connection between the horizontal compressed by a factor of 1 over 2, right? Half. So this was horizontally compressed, right? By a factor of half, 1 over 2. So with k, it will be by a factor of 1 over k. You get the idea. Horizontally compressed by a factor of 1 over k. Is that clear?
Yeah.
So that is the compression part of it. Correct. Now, let's see into the transformation equation as a whole. So can you read from your book? The transformation equation is y equals to a sine, I'm using a square bracket, k x minus, what do they write here? D or what alphabet they write?
D and then plus C.
Plus. Correct. I use P and Q, P for phase shift, and normally the books use D and C. Now, we have, what is K now? Tell me, what is the value and significance of K?
So K is how much it's compressed or stretched, and you can find it by doing
Horizontally.
Yes, horizontally. And
Horizontal.
find 2 pi divided by the value of K.
Correct. Horizontal compression by a factor of 1 over k. Very important. By a factor of 1 over k. Now, you will learn later, this is also related with frequency. So, and so many other terms. So how it is related? So we say time period. So we can relate this with time period t, which is basically now 2 pi divided by k. Do you see that? So the time period shrinks depending on the value of k if it is greater than 1, correct? So that will be the time period. K could be anything, correct? Of course. If K is greater, time period will be smaller. If K is smaller, time period will be bigger, longer, because K is in the denominator, correct? So to give you an example, if I have sine of half of x, that means time period is 2 pi divided by half, which is 4 pi. Do you see that? Longer.
Yeah.
It also means that there will be only half wave between 0 to 2 pi. You get the idea? So
Yeah.
this is very confusing many times. So we have to understand this. That really means that if I sketch the sine wave, in that case, if it is a sine half of x, in that case, only half wave will be between 0 to 2 pi. Do you see that? And the full wave will be 4 pi. Sorry, 2 times 2 pi. 4 pi. Is it okay?
Mhm.
Because the time period now becomes 4 pi. So that is the significance of K, which actually relates with the time period of your wave. Now, this time period has to be divided into 4 quarters to get the whole wave. Do you see that?
Yeah.
So, to get the whole wave, if it is 4 pi, I'll divide into 4 equal parts, and you can see how I have drawn my sine wave. Do you see that? Starting with 0, maximum, 0, minimum, 0. Do you see that? 0 maximum, 0 minimum, 0. Simple as that.
Mhm. So basically, it tells you how much like one wave fits, right? The distance.
Yes.
Okay.
Yeah. The wavelength. So this is length of my one wave. Do you see that? We also call this as a wavelength, right?
Mhm.
Or what you learn in physics. It's good to know all this, right? Or you can say cycle time.
But it's always only one wave, right?
One wave.
Okay.
This one wave is the length which we are talking about, right? The time for the wavelength, this is T equals to 2 pi by K. So there are so many related terms which you will get in application questions, correct? So that is how we actually correlate K. The other terms, A is the amplitude. Now let's talk about A, the amplitude. So A is the amplitude. Amplitude is by default 1. A is 1 by default, correct? So if the absolute value of A means, if it is minus 2, that means 2 times. The amplitude becomes 2 times, right? Minus has a different meaning. We'll look into that later. So absolute value of A is greater than 1. It means it is a vertical stretch.
Mhm.
But if absolute value of A is less than 1, right? That means like a fraction 1 over 2, 1 over 3, then it is vertical compression by a factor of A. We do not write 1 over it, by a factor of A. Is that clear to you?
Yeah.
But if the A value is negative, if A is less than 1, it means the reflection on x-axis. So it goes upside down. Do you understand like this?
Yeah.
Reflection on the x-axis. So that is a value, A, which gives you vertical stretch or compression and also tells you about vertical reflection. So it's all about vertical. You get the idea. Similarly, the value of C is actually vertical translation. This is vertical translation.
So almost identical to what we have learned in previous units.
Perfect. And here it is the axis which you talk about. So this is called the axis. So axis is equal to, axis is y equals to C. So C value gives you the axis for the sine wave. Is it clear?
Mhm.
Now, the last thing, which is kind of very critical and least understood, is the phase shift. For a sine wave, it starts with 0, correct? Now, instead of 0, 0 and going up, if it starts somewhere else, that is the phase shift we are talking about. This is D. Is that okay?
Mhm.
So that is the phase shift. So you have to figure out, when is the sine wave 0? Closest to the origin, right? When does it start and goes up? At that point, that is D. So if I have a sine wave starting from here, I will say, well, if this is like say pi by 2, so then it is starting at pi by 2. Is it okay? So D
Yeah.
value is pi by 2. So that is the transformation of sine functions in short, correct? Now let me give you one equation and ask you the question to understand this whole thing, right? So if I have a sine function, which is 2 sine, let's say, 3, let's say, x minus pi by 10 plus 1. So in this case, can you describe the transformation and tell me, how are you going to sketch this particular sine wave?
Okay. So the first, number 2, is the vertical stretch by
Yes,
2. Then 3 is the K value. So it's the compression.
very
So
good.
find the cycle of 1, you would do 2 pi divided by 3. And
Correct.
then, yeah. And then D is the phase shift, or negative pi over 10. So
Pi
that's
by
telling,
10, right?
yeah, to the right.
Correct.
So telling you where to start. And then number 1 is the vertical translation.
So axis
Mhm.
is y equals to 1 up.
Yeah, 1 unit up. Yeah.
Very good. Simple as that. And how will you sketch this? Easiest way to sketch is like this. You will actually simply draw the scale, and then you say, well, I have one particular cycle, and this cycle is 2 pi by 3, correct?
So
Time
sorry,
period,
how did you know? Oh, okay, yes.
2 pi by 3. I'm going to divide this cycle into 4 equal parts. Do you see that?
Yeah.
So each will be how much? This is 2 pi by 6, correct? This is 2 pi by 12. Do you see how easily I'm writing all the numbers?
Yeah.
And this is 2 pi by 12, 2 times, 3 times, 6 pi by 12. Do you understand? 6 pi by 12. Is it okay?
Mhm.
So this is 6 pi by 12, which basically means pi by 2. You understand?
Yeah.
So we have these cycles. And since it is a sine wave, I'll start with 0. I'll take 2. I'll go to the maximum, come back to the minimum, and then go to the minimum, I mean 0, and then go to the minimum and then up, right? So I have this particular wave, which is my sine wave. Is it clear? But this sine wave I've taken as 2 sine 3x only. Do you see that? I've not done the translations yet, correct?
Yeah. Yeah. Okay.
Now I have to move x pi by 10 units right and 1 unit up. So each point I will do pi by 10 units on my scale, right? And 1 unit up. Do you see that? So my axis basically moves by 1 unit. Is it okay? So I'm moving this point from here to here. Do you see that?
Mhm.
So every point I'm moving right and then this. Do you see that? And so I'm going to connect these points and draw my wave. And get the answer. Do you see that?
Yeah.
Correct?
Mhm.
This is the easiest way to sketch. Let me show you once again. Did you understand this process?
Yes.
I'll show you alternate method. I'm now writing another equation. So I have y equals 2. We'll work with sine first, and we'll take cosine, right? Don't worry about it.
Okay.
So
Yeah.
minus, there's a 2 sine. And I'm writing here, be careful. See, look here, what I'm trying to do. Half. I'm writing half here, which is k value. X minus pi by, let's say pi by 6, okay, plus 3. Now in this case, how are you going to sketch? Tell me, how will you do? First thing first, most important is, you notice that this is not factored inside, correct? So you should write this equation as minus 2 sine half, factor this out. You get x minus what? You have to multiply this by 2, pi by 3. plus 3. You understand this?
Yeah.
Because if I open the bracket, I get half x as I have here and pi by 6, correct? So it is correctly factored. Now it is very important to write this in this particular form by factoring out k, so that you understand that the phase shift is pi by 3 units to the right. You understand this process? Now I will show you two-step method to sketch the graph. Very important. How am I going to do it? I'll show you. In first step, I will do everything except for this part, phase shift. I will do phase shift in the second part. Okay. And let me show you how am I going to do it. Okay. First thing first, we have the axis at 3, correct? Y equals to 3 is my axis, correct? Amplitude is 2. That means maximum will be 2 units above it, correct?
Yeah.
And minimum will be 2 units below it, correct?
Yeah.
So now let me just make the scale. Okay, I could have used a different thing, but anyway. So this is 3, this is 2. Let me just actually draw a line here for x. Is it okay?
Okay.
So that's my origin, correct? I'm saying this is not to the scale. I'm saying this is like 3. And so 2 units down, this is 2 units, correct? So that will be 1, correct?
Yeah.
And this is 2 units up. So that will be 5, correct?
Yeah.
I know that my time period is how much? Time period is 2 pi by half, correct? Or 4 pi. Is that okay? So here it is 4 pi. One full cycle is of 4 pi, correct? I'm dividing this 4 pi into 4 equal parts. So my 4 equal parts are, this is 2 pi, correct? And then this is pi. This is another pi, correct? So I have 1 pi, 2 pi, 3 pi, and 4 pi, correct? Since it is negative, I have to start from 0 but go downwards.
Right. Yeah.
But I have to be on my axis, correct? I have to start always from the axis. So my 5 points are 1, this time minimum, 0, maximum, 0. So I have my sine graph. Do you see how easily I've drawn my sine graph? And this sine graph is minus 2 sine of half x plus 3. Do you see that?
Yeah.
Without any calculation. Did I do the transformation of points, image points, so many calculations? No.
No.
I've got accurate values on my graph. See the beauty. So you can learn the method of manipulating the points and do, which we'll do shortly. But see this method, which is unique and very efficient to sketch any sinusoidal function. Is it okay? So we divided the time period into 4 equal parts and moved from 0 to minimum this time because it was minus 2 reflected on the x-axis. Then axis, maximum, axis. 5 points done. Now, we'll do the translation of pi by 3 to the right. So this is pi. I'm dividing this into 3 equal parts, correct? So this much is my translation to the right, correct? So I'm translating each point to the right by pi by 3. Is that okay?
Yeah.
And I'm just connecting these points. Done. I've got my equation, which is y equals to minus 2 sine of half x within bracket pi by 3 with negative sign plus 3. Do you see that? How easily I've sketched without doing any transformation of point, which you showed me in the book.
Yeah. So you did every transformation together except the phase shift, which you did afterwards. Okay.
Two-step method. First step, just ignore the phase shift in the first step because you follow the 5 points moving for sine curve from axis to minimum this time, since it is negative, reflected on the x-axis, to the axis maximum to the x, 5 points. Then second step, mark out the phase shift and move each and every point by that distance. And you get your final curve, correct? You can use the points of image by for checking your information. Now, let me just show you what we are trying to do. If I have a point which is, let us say, xy here, then on the transformation, it will be x value will be twice the value, right? Half gets, so it will be 2x, correct? Plus pi by 3. This is the transformation to the image point. And the y values get multiplied by -2 and +3. Do you see that?
Yeah.
So now you can write down your 4 points, apply this transformation, and you'll get those 4 points, 5 points as these, which we have on the graph. You get the idea.
Yeah, but this method is more time consuming.
You have to now calculate, right? Of course, for
Yeah.
0, 0, it's not very difficult. You know, it is pi by 3, and then this is 3. Yes, which we have, correct? Pi by 3, 3. Do you see that first point? Then we have pi by 2, right? And 1. Now you keep multiplying and doing all those fractions. It's going to take forever. You get the idea? But if we have restricted time, the method which I have discussed with you is fantastic. You like that?
Yeah.
That is how you have to do it. Now, as I told you in the beginning, sine and cosine are exactly same. The only difference is that the cosine starts with maximum. So let me take one example. So y equals to minus. I'm again taking minus half cos, right? So let me just write 2x, and let me write this as minus pi by, let's say 4, right? And then plus, let's say, some value 1. Is it okay? Now tell me, what is the time period for this?
2 pi divided by 2. Yeah.
Pi. What is the phase shift d?
Move to the right by pi by 4.
You have to factor 2. So you should rewrite this first thing first as minus half cos, factor out 2x minus pi by 8 plus 1. So d is pi by 8 plus means right. Is that clear to you? This is a common mistake. Always factor k because it's k x minus d. Do you see that? General equation is y equals to a. Let me write cos this time. K x minus d plus c. X minus d is in the bracket, k is outside the bracket. So you have to factor it. Otherwise, you get a wrong value of d.
Okay.
So you factor, we know d, we know c is 1. That means c is also called the axis, correct? Y equals to 1, correct? So you understand now all this, and amplitude A is half this time. And there is a reflection on x-axis. Is that okay?
Yeah.
So these are all the transformations. Now here is a very critical point. You have to write transformation in a particular order. The order of transformation is very important. So let me write that here. Order of transformation. Order is, if you look at the equation, go from left to right. Which basically means multiplication first. Followed by translation. Multiplication I wrote because it is reflections, stretches, and compressions. Is it okay? Followed by like a rule, Batma's rule, order of operation. You get the idea. But if you move from left to right, automatically, these factors are multiplication factors. And the later two factors are translation factors. You will never make a mistake. You get the idea?
Yeah.
You could mix and match. You could do horizontal stretches and compression before vertical stretches and compression. You could do that. But then always translations up and down should be the last two operations.
Okay.
In my method of sketching, as you have seen, I have kept this as my last operation, phase shift. So keep that as the last operation, you'll never make a mistake. You get the idea? So it actually also goes with the order of operation many times. If I have to write the order of operation, I will actually write stretch factor and the reflection first, and then we'll discuss the translations. Is that clear to you?
Yeah.
Perfect. So let me clear this. And now we'll again sketch the curve, which is y equals to, let's write down half minus I'm writing, okay, cos. And let me factor this time. What it would any number, right? So we should have, let's say 2. And let's say x minus, let me write down here pi by 4, okay? And here, let's me write plus, let's say plus 1, correct? So we have this equation for cosine function. We need to sketch this. How will you sketch it? Can you tell me, Chelsea?
So again, you go from left to right.
Yes.
So first thing is a horizontal compression.
No, this is a reflection on the x-axis.
Yeah, vertical, sorry.
Vertical. Okay. Reflection on x-axis.
So reflection and then compression.
This is compression vertical, right? Vertical compression.
Mhm.
By a factor of half. And this is
Horizontal compression.
by a factor of half, correct?
Yeah.
Horizontal compression by a factor of half. This is translation right, translation up. Clear.
Yeah.
Now, what is the amplitude?
Amplitude is 1/2, yeah.
What is the time period? K is 2. What is the time period?
2 pi divided by 2, which is 4 pi,
Pi.
sorry. Yeah.
And what is the phase shift? D is pi by 4 and C is what? Correct.
Mhm.
So C gives you the axis to sketch. I actually start with the axis, okay? So let me draw the axis first, which is at 1, right? So let's say this is my 1 unit. Okay, so I'm drawing this axis. So basically, I'm saying on my graph, this is the point 1 unit above the x-axis. Is that clear?
Mhm.
Now, what is the amplitude? Amplitude is of half. So see, I'm drawing a half from here. So this is my max minimum, and that will be my maximum. Is that okay?
Mhm.
So this portion here is half, correct?
Yeah.
The value of A. And as soon as I write half here, I know this is 1.5 for me now, and this is 0.5. Does it make sense? Easy, right?
Yeah.
What is my time period? Pi, correct? So I'm
Yeah.
saying, well, that is my one wave whose time period is pi.
Mhm.
I'm going to divide this into 4 equal
section.
parts.
Yeah.
Do you see that? So pi by 2, pi by 4. So we count like this. Sometimes,
Mhm.
1 pi by 4, 2 pi by 4, 3 pi by 4. Do you see how easily 4 pi by 4 is pi? Very easy. We're talking about cosine wave, which has reflected. Cosine wave starts with maximum, reflected will start with minimum, right?
Yeah.
So we start with minimum, go to the axis, go to the maximum, come back to the axis, go to the minimum. We have our cosine wave. Do you see how easily I've drawn it?
Yeah.
Beauty. Next step, the only thing which I have not done is translating pi by 4, right? Let's do it. Let's do it. Pi by 4 is this, so I'm moving it right by pi by 4. Do you see how accurate the result is? Can you beat that? So that becomes my wave. You see, starting from here, I should start from here, move everything pi by 4. Done. It doesn't take more than 2 minutes to sketch any trigonometric function you may write. Did I use any table of values, 5 key points, image point? No. We do not have to use it. But if the question says, do it, okay, then you make your table. You know the transformation. So key point is to understand that if xy is my y, xy is the original value, then the transformation will be x values will be half of x plus pi by 4, correct? I have to do that calculation, yes. And then y value will be minus half of my y value plus 1. I have to do my calculation. You can calculate using calculator or you can use these points. No harm. These are exact points. You see that? To save time, we could do the reverse calculation. You get the idea. Why should I follow this particular path? No, I will not follow this path. When I have such a beautiful way of sketching sine and cosine waves, any trigonometric wave, even tangent, we can do like this. You understand now the whole thing?
Yeah.
Easy. Now what I'll do, the next part of it in 2 minutes. I mean, where I'll draw a wave, you tell me the equation. Is it okay? Because that's very difficult question otherwise.
Okay.
So
Yeah.
I'm just drawing a wave, and let's say we draw like this. Is it? I've made a very simple wave. So it, and I know this point. I want to give you this point. Let's say this point is 6, and this point is, let's say, 1. I just wrote, right? And let's say that from one wave, we are just making one wave just to be simple. We'll complicate, don't worry. One wave as, let us say, 700, let's write 2 pi. Is it okay? Not 2 pi. Okay, let me write this as 4 pi. Is it okay? Can you tell me equation of this sine wave?
So first we do y equals sine, and then first we have to find the amplitude.
Yeah, amplitude. So we know that the maximum is 6, right? Minimum is 1. So the axis will be what? Axis is average. Axis is maximum plus minimum divided by 2,
Yeah.
which is 6 plus 1 divided by 2, which is 7 divided by 2, 3.5. Do you see that?
Yeah.
This is actually the value of C in your equation. Y equals to A sine K x minus D plus C. Is it okay? So we got the value of C.
Yeah.
Now, what is the value of K? K is 2 pi by time period, which is 4 pi. Is that okay?
Yeah.
So K is half. So I know what K is. What is the amplitude? A is maximum minus minimum divided by 2, right? So 6 minus 1 divided by 2, which is 5 divided by 2, or 2.5. Do you see that?
Yeah.
What is the phase shift? 0, because it starts with the origin. And therefore, what is the equation? Y equals to the amplitude 2.5 sine of the K value, which is half, correct? X minus nothing, right? So let me write X. And plus C, which is 1. Do you see how easily we got the equation?
Yeah.
Done. Another equation for you. So this is how easy it is, right? So what I am going to do this time, I am just going to sketch a sine wave, which is not starting with the origin. Okay, very good. Now what I'm telling you is this point here, which seems to be at the minimum, is at, let's say, pi by 4, and this value is like minus 4. Okay. And this value here is at, let us say, I'm giving you the maximum value this time, not the 2 minimums. Do you see that? I'm keeping it simple. And let's say this is, let's say it is, tell me some number. Let's say this is pi. And the maximum value here is, let's say, 6. Now, if that is the case, in that case, we know what is the maximum? 6. What is the minimum? Minus 4, correct? So what is the axis? Which is C for us, is basically add them, divide by 2, right? 6 plus minus 4 divided by 2, which is 2 divided by 2, which is 1, right? So the axis is at 1. Do you see that? What is the amplitude? Amplitude is different. 6 minus 4 divided by 2, 10 divided by 2 is 5. Is that okay?
Yeah.
We know that from here it is 5 units up, right? So let me just fill in these values. This is, we found at 1, and so this maximum will be at 6. It makes sense, right? 1 plus 5 is 6. Does it make sense? 1 plus 5 is 6, correct?
Yeah.
So amplitude is 5, correct? Now, what is the time period? Time period is from maximum to minimum. This is half the cycle, correct? The full cycle is here, correct?
Right. Yeah.
So half the cycle is, so time period will be 2 times. Half the cycle means pi minus pi by 4. Is that clear? Which is twice. 4 minus 1 is 3. 3 pi by 4. Or I could write this as, when you simplify, 2 and 2 cancel 2, so you get 3 pi by 2, correct? So the time period for this is 3 pi by 2. How did I find it? I found the difference between pi and pi by 4, this much, correct? 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4. You understand? So I got pi minus pi by 4, which was 3 pi by 4, correct? Because this is half the cycle, I multiplied by 2 to get the full cycle.
Okay.
So I get 2 times 3 pi by 4, which is 3 pi by 2. So the time period is 3 pi by 2. It's not an easy question. Very difficult. Now I got the time period. From this time period, I can find what is K. K is 2 pi by T, which is 2 pi by 3 pi by 2, correct?
Right.
Let me write it. 3 pi by 2, correct? So pi cancel, right? 2 goes up, which is 4 by 3. Do you see how difficult value it is? 4 by 3 is my K value. And what is the phase shift? Phase shift. To find the phase shift, we know sine wave starts with the axis, correct? So if I have to write the sine wave, I have to figure out where this point is. This point is midway between pi and pi by 4. Add them, divide by 2 to get this point. You get the idea? Do you see how it is difficult question, correct? So to find this particular point, which is midway between pi and pi by 4, we'll do pi plus pi by 4 and then divide by 2. Is that okay?
Okay.
And then you get the shift. So 4 plus 1 is 5. 5 pi by 8. That is the quarter. Do you understand? That is the phase shift. And you see how complicated equation we landed with this particular graph, which I draw at random. This is a difficult test question for you. So here we get y equals to the amplitude, which is 5 for us. Let me write down in middle somewhere, right? So we get y equals to the amplitude, which is 5. And then we have the sine function k value being 2 pi by, k value being 4 by 3, x phase shift being 5 pi by 8, and y moved 1 unit up. Do you see how complicated it was? But we could solve it with our minimum learning about this particular topic. Extremely complicated question. It was easier to give a cosine function because we could have written minus cos. We are starting with minimum. Do you understand?
Yeah.
Shifted by pi by 4 on the right. Shifted by pi by 4 on the right. Do you understand? Sine wave is quarter of the cycle starting later, as you can see, quarter of the cycle. This is actually quarter of the whole cycle, which is time period of 3 pi by 2. Do you see that?
Yeah.
And that is how we can actually solve such questions. Do you see that? Okay. So when I did pi minus pi by 4, actually this was 3 pi by 4, not 5, 3 pi by 4. Pi minus pi by 4, right? Let's redo it. Pi minus pi by 4 means 4 pi minus pi by 4, correct? Which is 3 pi by 4. So this is 3 pi by, this shift is 3 pi by 4. Is it okay? Half of that, 3 pi by 8.
Okay. Yeah.
Not 5 pi. What I'm saying is not 5 pi, 3 pi by 8. Quarter of this cycle. Quarter of 3 pi by 2. If you divide this by 4, you get 3 pi by 8, right? 4 times 2 is 8. So I could have directly got from here. Quarter of this cycle. 1/4 of 3 pi by 2 is 3 pi by 8. So that is why it was 3 pi by 8. Not 5 pi by 8. That's what I'm trying to tell you, right? So good. I could correct it. Now, do you understand what we did so quickly here? I'd like you to watch this video once again so that you understand what we did. But now, can you summarize our learnings for today?
Yes. So today we learned what a sine function looks like on a graph. We learned the similarities between sine x and cosine x, that they're very similar. It's just that cosine starts at the minimum or maximum. We also learned the different components of the equation for sine, so the different transformations, so vertical stretch, compression, horizontal compression, translations, also phase shift, remembering to factor the k.
Yes, very important.
Very important. And then we also learned when you're given a graph to then find the equation that goes with it.
Correct. That is right. Okay, then we'll end the class here, Chelsea. Very good to have this lesson with you. Please feel free to write your any doubts if you have. Send them over. I'll answer your questions. And practice.
Yes.
Okay, great. Thank you and all the best.
Thank you.